Welcome. We'll try to keep you awake. I know after lunch it's a little harder than usual, but see if we can be entertaining enough. So this afternoon, first session afternoon, we will talk about modules, cores, and build services. My name is Robert Schweikert. I'm a public cloud architect at SUSE. I work in the overall organization within the ISV engineering team. I'm also team lead of the public cloud team, and we have basically anything that has anything to do with the public cloud goes through my team in some way, shape, or form.
Hello, my name is Stefan Behlert. I'm one of the release managers in the enterprise department. I'm responsible also for the server stuff, and I'm glad to be here and that you have time to listen to us. So let's start.
All right. Let's take a look at SLEs in general and where what our customers generally expect from us, right? So generally, enterprise customers want slow changes or better no changes at all. Don't ever touch a running system. And of course, application vendors kind of want that as well, right? Because they want to write their application and test it and then run it. And then as long as you don't touch the underlying operating system, the application will continue to work. Of course, on the other hand, everybody also wants to stay current, right? Oh, look, there's this latest new fancy chip that has all these fancy new instructions, and we want to take advantage of those so that our applications runs faster. And so somewhere we're stuck in the middle, and we'll get back to this this picture in a little while. So the agenda really for today is to give you an overview at the world as we know it today. Again, we'll come back to this picture, talk about customer expectations. We'll talk about the principles that we follow at SUSE for development of SUSE Linux Enterprise. And then, we'll describe the problem in a little more detail. Then we'll look at SUSE Linux Enterprise 12. With the original release, we took a new approach, and that approach is being carried forward through the service packs. And of course, through the end of life of SUSE Linux Enterprise 12. Basically, we've taken a divide and conquer approach, and we'll introduce those, and then we'll take a little deep dive into each of the modules that are coming along with SUSE Linux Enterprise Server 12. And then, of course, there's always the question of, you want more packages. So we'll talk about the OpenSUSE BuildService. We'll talk about the solid driver program. And we'll talk about Backports project that you've also heard about this morning in the keynote, which is known as Package Hub, which is really coming into full swing now that we have released SLES 12 SP2. And with that, let's take a look at the world as we know it today. Again, back to this picture. So again, the basic expectations of customers in the enterprise, where many applications run on servers, also known these days as pets, right? We name those servers, we care for them, we update them. We love the servers, and we don't ever want to shut them down or reboot them or whatever. So here in that world, customers expect stable interfaces. Of course, they want no bugs, but we all know it's software, so we can't have no bugs, but we want as few as possible bugs. If anything needs to be fixed, we want targeted bug fixes and not wholesale upgrades. Because if we wholesale upgrade something, we might get new bugs that we didn't know about previously. Of course, no regressions is always wonderful, and we want to support as many applications as possible, right? And if you have an operating system that moves every day or every other month, application vendors are not going to be very happy with you because they think they have to recertify and retest every day or every other month or whatever. On the other hand, of course, that goes back to the staying current theme. We have customers, again, want the latest hardware support. Intel, IBM with Power and System Z, they certainly don't care about our release cycles, right? They have their own release cycles, and when there's a new processor, new chipsets, new graphics cards, customer want to take advantage of that. At the same time, of course, the open source ecosystem moves incredibly fast to begin with, right? The Linux upstream kernel has a release about, every 8 to 10 weeks with new features and bug fixes. So there's a lot of innovation happening there, but not just in the kernel. There are many things, where innovation is happening. Also, as we look at bigger systems, NUMA is changing all the time, things like that. So there are new features that come about. And of course, there are different form factors, right? I mentioned I'm the public cloud architect, so it's just in the public cloud from our team, we support different frameworks, so there's already 3 form factors there. Then we have the ISO images that all is done through Stefan. He's watching over the production of those and how they get built and how they get put together. Then we have form factors for different virtualization types, and of course, Docker, the hot topic. And overall, we need to stay current. So there's clearly a disconnect, right? We're looking at 2 extremes of basically one spectrum. And then, of course, there is support. Customers of an enterprise distribution, expect that they can call us, email us, and they get help. They get bug fixes, security updates, and of course, probably fresh in everybody's mind is Dirty Cow, but not so long ago we had Shell Shock and all kinds of wonderful things, and we have to deal with those as well, right? Customers also want easy migrations from one service pack to another, and with SP2 we're actually introducing the ability that you can skip a service pack when you update. So if you don't want to go to Service Pack 3, for example, and you're in Service Pack 2, then in the future we'll be able to skip Service Pack 3 and migrate to Service Pack 4. So that is a new feature in SLE 12 SP2. And of course for security fixes, and we have a member of the security team here, they work very hard to provide timely updates. Generally the goal is especially for critical security updates, to always have packages available when the update gets announced. And that works really well. So, and from that, basically from those requirements that we have from our customers, SUSE has derived certain principles, and we make promises to our customers and our partners. First of course, is API and ABI stability. That is primarily targeted as ISVs, right? But also, of course, for corporate developers that want to use, they build in-house application. But for ISVs, API and ABI stability is really important, so that they don't have to go in and fix their application, every month or whenever you break, something changes. So what that means, basically, especially in the kernel perspective, when new features come about in a service pack or then they get supported later, these features get backported rather than making a wholesale upgrade of the kernel. Although we do make kernel updates. So for SP2, we rebased the kernel to 4.4, and in /12GA we were on 4.1, right?
3.12.
Oh, 3.12, yeah. 4.1 was in OpenSUSE Leap 42.1.
Right.
So sometimes we do make the upgrades of the kernel, but we keep the ABI stable. Okay, so we have a special process that the kernel team follows, where we have an ABI checker and we make sure that the ABI stays stable even if we make major kernel jumps. Of course, another SUSE principle is that everything is supported. So everything that Stefan puts together that ends up on the ISO image, everything that's in the modules, everything is supported, which means you can call SUSE if you have a support agreement with us. Some packages that we ship require special support agreements. I think MySQL is one of those, and there are a few others that are floating around that are like that.
2 or 3 of the packages, mostly in the database area, but most of the stuff. So not counting those 2 or 3 packages, it's 99.9 something.
Right. That are supported by us. And that also means if something is in SUSE Linux Enterprise and the upstream project goes away, or they no longer support a specific version, it will be continued to be supported by us. For example, OpenSSL is a really good example, right? The upstream project is no longer supporting 0.98, but SUSE Linux Enterprise 12, which uses 0.98, has end of life in 2019. So SUSE will continue to support OpenSSL 0.98 within the frame of SUSE Linux Enterprise 11 until the end of life, so 2019. And then, of course, you can get 3 more years of LTSS after that. More on the support and the time frame later. So, in SLE 12, in order to address the ends of the spectrum, right, really, really slow or really, really fast, what we have come up with is basically we introduced modules, a divide and conquer approach. And basically that means we sat down and we defined groupings of packages. And there's a base group of packages, and that we can call SLE core. And around that, we built these modules. And I don't know if you had a chance to see Matthias Eckermann's presentation about the future of the OS. He actually showed a few pictures about this. The base group of the packages, they're all on the ISO. So when you go down to download.suse.com and you download SLE 12 SP2 ISO image, the files that you get on there, the packages, those are all part of the core distribution, okay? And we'll talk about the life cycle of this in just a little while. The core also contains packages that are shared between multiple modules and if it fits within core, okay? This base group is not a pattern, okay? So this is important to remember. This is not a pattern, but it contains pattern. So this is a definition that we came up with to decide, this was going to be the core of the operating system. And currently that stands at roughly 3,300 binary packages, right? And Stefan can give us a little more insight about how we came up with this definition of the core packages.
So the definition came up when we thought what is needed by everybody. That's the main criteria that we had on that. And everybody does not only mean user-wise, but also if you look at various products, we have the server and on top several extensions, several other products that use that. And we're looking which of these packages that we had. We had to choose from a variety of several thousand packages there. And in the end, it boiled down that there are some packages that are used by nearly everybody, some that are used by everybody, the kernel comes to mind, and some that are only used by different groups of users, not so far by different products. So all that we saw that is used by a huge number of people at the same time, or by several or more than one product, we put into the base group, and that's what makes up the server in the end. So everything that is not falling under that, we divided up into some logical functional groups, which we called then the modules. So we grouped that according to the function that they serve. For example, we have a webpack scripting module, we will come to that. That contains everything that is around of that. We have a legacy module that is around all the stuff that is more falling under the old stuff or the more legacy stuff. So this is the functional line of diversity that we choose. because if you're using, for example, web and scripting, you're more likely to use more than one of these packages, not just one. So we group that into one module. We tried also to avoid cross-dependency problems. That means we don't want that if you have one module that you have to install another module just to use one package inside. Packages that are required there, we tried to put into the core module. We had one or two exceptions, but in the general, this is the case. So,
right, and so where we do have these exceptions, we actually copy the same package into two modules so that we don't have inter-module dependencies. But the package, as it shows up in both modules, you can install either one, and they have exactly the same version and the same files, so there are never any conflicts when you install a package, even if you have both module repositories enabled.
Yeah, that saves you from downloading too much or more than you really need. We have currently 7 modules. An 8th one is upcoming, but we will hear more about those.
Yep. So along the divide and conquer from the module perspective, we apply the same principles that we discussed earlier, right? We want, but they have their own life cycle. Okay, so the life cycle varies, but the principles are the same. We don't want to break our customers, but in the modules, we're not as strict about it as in the core, okay? So the life cycle of these modules is very, it's dependent on the functionality of a module, and it is different from the core. And within the modules, at least within some, version changes can be expected. Okay, so we do make version changes in the modules that you would not see if the package were in core, right? And that allows us, for example, for fast-moving technology, these last few days and tomorrow too, you hear a lot of Kubernetes, for example. Kubernetes is fast-moving technology. That's not something we want to have in /core, because there we wouldn't want to do version updates, right? And then we would have a problem. And so that is going to end up in a different product or in a module that's kind of still being worked out. Okay, let's take a look at the module definition. What is this thing that we call a module? So first of all, it's a collection of software packages that, as Stefan already mentioned, we decided to group by logical functional cohesion. So web and scripting, for example, there's a containers module, right, that provides things that are related to containers. But again, all packages have L3 support, but the scope may be limited, right? So if you use a package from module A that has a certain intent and you use it for something completely different and it's broken in that context, then L3 may not be as fast as you would expect if it is used in the context where it is intended, okay? Each module, as we already mentioned, is independent of another, so there are no inter-module dependencies at this point in SLE 12 by design. And the module is delivered as a repository, and as a repository only. So there are no ISO images or anything. These module repositories are online repositories only that are delivered through the SUSE Customer Center. Okay, and they're in addition to the base product, and they're really included with SLE 12. So there's no extra cost or anything. They're a part of SUSE Linux Enterprise Server, but they're in addition. Again, this is software that you add on, but they are a part of the distribution.
The only requirement is you have to register.
Yes. So, and you can do the registration of the modules during installation or later on with SUSE Connect when you come up and decide you need an extra module, then you can use SUSE Connect to register. If you're running in the public cloud and you're using an on-demand image, all the modules get registered into the instance automatically. So all the repositories are immediately available to you there. The modules do have a different life cycle. follow the overall life cycle of SLE, but that is different than the 10 years. And we'll talk about each module in detail and explain the life cycle there. And the packages within each module may also have a different life cycle. So, the implementation. Again, they're delivered as a repository that can be added during installation or later. You can use Yoast or SUSE Connect, available online. And there's always a pull repository, which means this is the state as released. And there's the update repository, which means it contains the code when it gets updated for whatever reason. That may be bug fix, a version upgrade to add new features, security updates, or whatever comes along. And again, a module is not a pattern, but it may provide patterns, okay? And it is not a product with a SKU for purchase. Modules are part of SUSE Linux Enterprise Server. So when you enter an agreement with SUSE to get an entitlement for SUSE Linux Enterprise Server, the modules are part of your entitlement, is what you get, okay? And again, keep in mind that the module's primary objective is to solve the problem of really, really slow meeting really, really fast, right? And how do we deal with that? So here are the modules in a quick overview that we have today. There's the Advanced Systems Management module, which contains configuration management tools. So CF Engine, Puppet, Salt, Machinery, they are all delivered in configuration management module, and that has a life cycle of continuous integration. And we'll talk about more what these life cycle means. The container module delivers Docker. It also delivers pre-built containers, okay? So the container module delivers SLE 11 and SLE 12, SLES 11 and SLES 12 containers. So you can use that container module as a target for your Docker file, and then when you run Docker build, and you can say from SLES 12 SP2, and then Docker will build the container starting from the container that we built originally that is part of the Docker, or part of the container module. It also contains other container things, in this case something for the public cloud, where we have a module that, a package that provides integration with the Amazon Elastic Container Service, okay? And again, although this is really something that's specific to the public cloud, it is also related to the container module, and because it needs things from the container module in order to not have the inter-module dependency, the ECS integration comes from the container module. And the life cycle here is also continuous integration. And on the legacy module, that's really the old stuff, right? If you're still using interfaces from way, way back when that have been deprecated by many standards bodies and others, you can still find them here. SendMail, old IMAP stack, Java, etc. This has a restricted life cycle of 3 years. So this is actually coming up on the end of its life cycle. So from the beginning of SLE 12 GA, 3 years forward, and then this module will no longer get any updates, okay? It will still have the packages, but it will no longer get any updates. Then we have the public cloud module with instance initialization code and command line tools, also lives with continuous integration. We have the Toolchain Module, which has a yearly delivery that's providing GCC, web and scripting, PHP, and Python, Think web application. Here we have 3 years with 18-month overlap. We have the certification module, which provides FIPS, and basically those are frozen versions, okay? Because in that realm for security certifications, we can't do any updates, period. That's the requirement. And if you do any updates, then you have to recertify. So that's why this is frozen. And so those are pretty much the modules that we have today. And now we're going to go and explain what these lifecycle things mean. So continuous integration, and I'll talk about that, and then I'll let Stefan talk about some of the other stuff. Continuous integration doesn't mean that every day we have stuff that we pull from GitHub and so on. What it means is that we integrate new features basically through version upgrades, okay? So when there's a new feature that we need or that a customer wants, if the package lives in a module that lives under the continuous integration lifecycle, then that package will just be updated rather than the features being backported, right? So if you contrast that, for example, with the kernel, that of course lives in core where there's no version upgrades, when there's a new feature that is decided that needs to be in the kernel, then that feature gets backported from an upstream version into the kernel version that we have. Under continuous integration, that would just mean we just update the package, right? So if I have package version A or 1 and there's a new feature, then we will release package version 2. Okay, so that comes with version upgrades. Bug fixes generally also get done through version upgrades, so we will not necessarily backport bug fixes if there's a module that lives under continuous integration. But as I already mentioned, this is not the version of the day, right? This is when new features are needed or bug fixes are needed. And then the updates are delivered through the update repository. The yearly life cycle, and this is what the tool chain is under, is a bit different, and Stefan can tell you how when you jump on the train, then you got to keep going.
Yeah, yearly is a little bit misleading maybe, because in fact it's a fixed cycle. For the tool chain, we have it with 1 year. For other packages, it's a little bit different. We will come to that later also in the web and scripting, where we have an example for that. So the fact is, there are programs, once you have switched to a newer version, it doesn't make sense to have the old version any longer or to use it for a longer time. The GCC is one of these where we say, once we have a new GCC version, the old GCC version doesn't make sense to keep it. We keep the runtime. We have the runtime for all of those so that it's working, and we keep the system compiler. So if you have a SLE base product installed, you will find out that there is already a runtime for the GCC stuff, as well as you get through the SDK, the system compiler, which is the GCC 4.8 currently for SLE 12, and we keep that compiler for the whole lifetime of code 12. But as you may be aware, new things come up, GCC improves, new technologies, new platforms pop up. You want to have those also supported. You may need a newer compiler to get your application running on that. So we have the Toolchain module there, and we refresh this. Once we have a stable version of a new major GCC version, in this case, recently we had GCC 6 released, we release that and provide also the binary stuff that is needed to run then the application that you create with that. Next year, when GCC 7 will be available and we have a stable version of that we think is good enough, we will release that, and GCC 6 will be gone. Simply because it doesn't make sense to have it. GCC 7 has then all the bug fixes that you need. The runtime will allow you to still run the old stuff that you have created with GCC 6, and it will allow you to run new stuff with GCC 7. So when you use that and you say you need a new compiler, you then have to go there forward and use the next version. And it's, in most cases, the best choice, to be honest, especially with GCC. For example, if you are one of the new ARM, if you have seen the ARM product there, GCC 4.8 and ARM, yes, it works. Do you want to use it for your own application? Most certainly not. So you want to go there with the newer stuff, the newer bug fixes, and backporting that is not really an option. Right. So therefore we have that fixed life cycle.
Yeah. So basically on the yearly, once you're on the train, every year you're going to keep moving. You can't decide, oh, I like this station and I'm going to get off the train and stick with GCC 5 when GCC 6 comes out, right? So once you're on the train, you're going to keep moving. Plus, in the end, for your applications, you want to do that anyway because, you know, every time GCC, Intel releases new instructions and then obviously they don't get backported, they just show up in the new version of GCC, for example.
And to make it clear, if you have installed it, it will of course not be removed.
Right.
Just if you do a new installation, you need the new version.
Right.
Because the old one is no longer there.
Yeah. So, let's look at the Advanced Systems Management module, and we touched on the modules briefly in the table, so we'll just go a little bit deeper here. Continuous integration, again, so for example, machinery is getting developed, they're getting a new version that can do new stuff, then that package just gets updated in the module, rather than things being backported or, and for bug fixes as well. You just get a new version. The Advanced Systems Management module also includes configuration management tools, except for Chef, which happened to end up in the SUSE base product because other components of the SUSE application and ecosystem need Chef for their purposes, and so Chef ended up in the core. The dependencies itself, as we mentioned already, there are no intra-module dependencies, right? So the dependencies are contained to this module. Okay, containers, again, also lives under continuous integration, so that means Docker 1.x comes out, we test it, we run it, and the bug fixes and the new features that come with the new version of Docker after our testing and whatever, they just flow right into the container module, and that then shows up in container update repository, okay? Includes container management tools, so orchestration stuff would end up in the container module, things like that, and container integration tools, right? So things that you need to integrate with containers, or as I mentioned with the Amazon Web Services container service, they end up in a container module. And of course, the base container images that our container team builds, right? And therefore, /11 SP4, /12 SP1, /12 SP2.
SP2 is coming.
And
I have to say, that's the disclaimer. It was just released, so bear with us. It will take 1 or 2 days more.
Right, but but of course the SLES containers fall under the general lifecycle, right? So if you're using a SLES 12GA container that is in the container module, then you need to have LTSS if you expect to have support, okay? And other than that, you would just keep moving with the distribution. The legacy module, okay, so as I mentioned earlier, this is 3-year life cycle, and then we're done. So that means those packages will no longer get bug fixes, okay? Why do we have this to begin with? Well, application migration, okay? So we want to help our ISVs to move forward to, let's say, newer interfaces that have not been deprecated or whatever, and this is why this is there, okay? Basically to support what can be considered older technology. If you're starting something new and you're pulling functionality from the legacy module, well, then you should not really be doing that. The legacy module has the advantage of that it makes it very explicit to you when you end up with an application that depends on something old, right? So it is not registered by default when you install SLES. And then when an application doesn't work because of some shared library is missing and you find that shared library in the legacy module, then wherever you get that application from, you can go back to your ISV or to your in-house developer and can say, hey, you're depending on something that's really old and that's going away. Please go fix the application, right? So while this may seem a little painful, it is really helping you to find those corner cases where people depend on stuff that they shouldn't be really using anymore. And also many of these older interfaces that are found in here, they may not be thread safe, or they're insecure by design where that can not really be fixed, right? So all of that stuff is in here, And again, be careful when you're using packages from this module. Not as far as being careful as, it's broken, but it is an indication for you that this is stuff that is going away, right? Public Cloud Module, near and dear to my heart, of course. It lives under continuous integration. Generally, you find actually 3 categories of packages here. Instance initialization, right? So when you run an instance in the public cloud, that instance needs to get initialized with network information, user information, password or SSH key, and some other things. So that's one set of packages and that we maintain here for all 3 cloud providers, Amazon, Microsoft Azure, and Google Compute Engine. Then there are cloud management tools, which means command line tools that help you start, stop instances, and manage cloud services. And then tools that are specific for cloud service providers. So that help cloud service providers where we, for example, don't manage update infrastructure, set up their own update infrastructure, and things like that. And again, no inter-module dependencies, so this module brings with it all the dependencies that it needs for all the code that's in here. Toolchain.
Yeah, already mentioned. Currently, GCC 6 came out 2 months ago, I think. New version once every year. You may ask, why is that? Because that's roughly the circle that GCC has. Currently, they bring out a new major version every year. Then the first version is normally not that you say, yes, you should use it widely. There are 1 or 2 bug fix releases. And so in the end, you have every year 1 release that is rather stable and that you can use, and we follow that year-long life cycle. Right. Important, the system compiler is not touched by this, so the system compiler stays the same. So even SP2 is compiled with the same compiler we used for 12 GA. So you have no discrepancies here, you have no incompatibilities, but the runtime library that is used and that is required to use the new GCC that is in that module is also available in the base product. So you have everything here, but also in the base product. It's one of the exceptions that we have because we release later also when it comes to 7 then the base libraries as an update.
Right. So what you have to keep in mind here is when you use the toolchain module and you move GCC forward, okay, again, the system compiler stays the same. And if you have the system compiler also installed, then that is actually the default compiler, right? So if in your makefile or your build system, you just say GCC, you will get the default compiler, which is the OS compiler that we released. So you need to adjust your build system of your application to take advantage of the GCC version that is provided with the toolchain module.
And the only thing where you really need the system compiler is if you have a kernel module, so a module for the kernel itself, right. Then you cannot use the newer GCC. Right. You have to use the system compiler. That's due to internal stuff on the kernel and GCC side.
Right. Web and scripting has a 3-year life cycle with an 18-month overlap. So basically, this is shrunk from what you know from the SLE life cycle, right? The SLE life cycle is 6-month overlap. Here for web and scripting, we have 18-month, but the release cycles are a lot shorter, right? So SLE has a 10-year cycle, and the service pack have a 6-month overlap. And web and scripting has basically a 3-year life cycle where after 3 years we throw out the old stuff and we put in the new stuff. And for 18-month overlap, the old packages are still supported. Okay. So what's in here is PHP 5, and recently we added PHP 7. And so PHP 5 will still be there for a year and a half, 18 months, right? Node.js, an example although Node.js I think is moving in its own module now.
Oh, maybe we will see. Currently we have it added to that module. You will see a new version of Node.js a little bit earlier than the 3 years because we jumped on the version train there relatively late.
Right.
And we want, of course, for you that you get a good version to work with and also the latest one. But we didn't want to wait until the next cycle there starts and we have a stable version because that would have been another delay. So therefore, that's a little bit special, but we will keep the old version also for a while and then remove it.
Right. Certifications. So this is frozen versions of the packages. We will not update. So if you get packages from the certification module, which covers FIPS 140-2, those are certified packages. They don't get updated, or we would have to recertify.
Anyone here who is required to use FIPS certified packages? Okay, lucky bunch of group.
Yeah.
By the way, the base system will, SP2 will also get FIPS certified. We're currently in the process of that. So this is required if you use an older version. And if you go with SP2, you have to wait for a few weeks, months, depends a little bit on the certifier. And then we have the certification for that too.
Yep. And so now that we've seen the module, let's come back, to why we're doing all this fancy stuff. And it's basically, again, to bridge the extreme ends between don't make anything change, don't change anything, and go faster, right? So the modules with the individual life cycles help us to basically bridge that gap where the very core of the operating system goes very slowly, all fixes are backports, version changes happen very rarely, while in the modules we try to keep pace with what upstream's doing as much as possible and as much as it makes sense. So we have a distribution now where some parts move very slowly and other parts move very fast. And I would say it's been now a little bit over 2 years since SLE 12 was released, where we initially introduced the modules. And so far, I think we've made very good experience with this approach. Okay, now to switch topics a little bit. Of course, although we have 3,300 packages in SLES plus the modules, there are, of course, always more packages, right? OpenSUSE distribution these days, I think, contains somewhere on the order of 8,000 or 9,000 packages.
9, yes.
And so you can see there is a big discrepancy, right? So what do you do if you need more packages and they're not part of SLES? So for that, we have the Open Build Service. And one instance of that is the OpenSUSE BuildService. But you can install the Open Build Service on-premise in your own data center. And basically, this is a way to build packages and to build a distribution, right? So for SUSE, we build all our packages with the Open Build Service. And SUSE, we actually operate 3 of these build service, 3 build service instances. Okay, one is the OpenSUSE BuildService that is used by the community to create the OpenSUSE distribution, where there are 2, OpenSUSE Tumbleweed and OpenSUSE Leap. And then we operate an instance of the build service internally that we use to build SUSE Linux Enterprise. And then another instance is used to build partner packages, such as for the solid driver program, right? So Intel, for example, builds kernel module packages in that instance of the build service when they release a new network chip or something. And support in the kernel is a little ways out. Then they just build a kernel module that plugs into the current kernel of the current distribution. Anyone can run the build service, so you can get that. This is a project that's on GitHub. It also, I think, is packaged up as an appliance, so you can just install it as an appliance. And we have a number of customers, a number of people that use the build service. And a new initiative is that there's going to be a program where there's actually support available for the build service. That starts out, I think, with a pilot program of 10 customers. I don't think it's full yet. So if you're a customer that is using the build service and you're interested to get support for it, get in touch with us. So, so we're starting with that. Okay, the OpenSUSE BuildService is, open to everybody. So if you're just building open source stuff, go use the Open BuildService. Don't run your own. It builds packages for many distributions, not just SUSE distributions. We also build packages for Debian, Ubuntu, CentOS.
Even Windows?
So, anything that is open source, you can build for pretty much any distribution there. The OpenSUSE community, as I mentioned, uses it to build 2 distributions. One is Tumbleweed, which is a rolling release. You get 2 or 3, sometimes 4, sometimes 5 distribution updates per week. It depends on how quickly we can get the stuff through QA. And then OpenSUSE Leap is basically a combination of SUSE Linux Enterprise and newer stuff from Tumbleweed. Basically, OpenSUSE Leap is a marriage of the core from SUSE Linux Enterprise for a large part, and the user space is mostly new from Tumbleweed. So we marry those 2 together, and that becomes OpenSUSE Leap. There are submission rules for different projects. They have their own, and there's a 3-tiered development model. There's a distribution project that basically makes the distribution. Then there are develop projects that feed the packages into the distribution project, and the home project is where anybody can build whatever they want. So if you do go to the OpenSUSE BuildService to get any packages, most of the develop projects turn on builds for SUSE Linux Enterprise, and so you can get the packages built in OBS for SUSE Linux Enterprise. They're of course not supported, but it gives you a way to get the packages that we may not have. But there's another way to get packages that you may not have, which is the package hub, and we'll talk about that. And for anything that comes from the Open BuildService, use the OpenSUSE mailing list, and there are great people that are always willing to help if you have questions. Internally, we have a version of the build service. This is only accessible to SUSE employees. It has the same functionality than the Open BuildService, but we use that to build SUSE Linux Enterprise and other products. SUSE Manager, SUSE Enterprise Storage, anything that has the name SUSE and has full support comes from the internal build service, okay? It is linked with the Open BuildService, so we can easily pull packages that are in the Open BuildService into the internal build service. And as I mentioned, this is used to develop all our products, storage, cloud, manager, and SUSE Linux Enterprise. And then there's the solid driver build process, which is accessible to customers for downloading and partners for building packages, okay? And that builds packages only for SUSE Linux Enterprise. And as I mentioned, this is primarily used for kernel modules, right? For example, we have an RDMA kernel module that is specific to Microsoft Azure to run HPC in Microsoft Azure, and that kernel module is built in the solid driver build process. We integrate it into our images, but the update repositories are also available in the instances that you're running. So when we release an update, you will get an updated kernel module. This is used, by partners, and sometimes we build modules for the partners. And it provides multiple repositories. Again, Microsoft, Intel, and many others have kernel module packages in here. Then the package hub started with /12 SP1, but it's really ramping with /12 SP2.
Yeah, the package hub is another instance, you can say, of the Open Build Service. It's a project there, a repository. So the biggest difference there compared to what you otherwise see is that there are controlled submissions. So what we put into that repository follows the same acceptance process that we have in the internal build service. We have not mentioned it there, but there are stricter rules, or very strict rules, let's say it in that way. What we accept, how we accept it, what quality expectations we have, and what we regard there as safe to be accepted. The same processes that we have there and the same qualities and qualifiers apply to the package hub. So we are making sure that the packages that are there have enterprise quality. The check-in approvals are done by SUSE employees. They are looking at that. And they are making sure that we are not breaking the supportability of the products that you have, of the base OS. So if you install a package out of the open build service, you could, for example, take the kernel. It's there, you can install it, but then you lose, of course, the support state for that machine. Because if you have an own build kernel, we cannot support that. That's clear, that's natural, that's logical. For other packages, it's much more hard to see that this happens. And we make sure in the package hub that whatever you take from there is not hurting your supportability.
Yep. And so the rules, right, are clear and targeted for the supportability. So the people that look after the packages that are proposed for Package Hub, they make sure that the package that is submitted doesn't replace anything that is part of SLE. Right, so nobody can submit the Python interpreter into Package Hub, right? Because we deliver the Python interpreter with SUSE Linux Enterprise. So nothing gets replaced. This is only additional stuff. One example here is KDE 5, right? So if you're a KDE fan, you can get KDE 5 from Package Hub and then run SLE with KDE, okay? If you are a fan of KDE. So Package Hub is really, this is all additional stuff. And community members from the OpenSUSE community can submit packages to Package Hub. And then, as Stefan mentioned, they get verified by the SUSE packaging team.
It's only available currently for code 12, so not for code 11. We are sorry for that, but we had to draw the line at one point and to make it handleable.
Yep.
We expect that packages that are there are also in OpenSUSE Factory. And if you ask, will packages that are in that repository come to the SLE 12 code base and the products there at one point in time? Yes, that's a possibility. We don't have that yet. We are still ramping up there. But that is a way, if we see there's a lot of requests for packages there, we will consider of putting it into the generic stuff.
Right. So basically, if you need to go outside the SUSE Linux Enterprise repositories to get software that you need for your project, application, or whatever, there is a hierarchy that you want to look through, right? First, you want to go look at Package Hub to see if it's there. That will be, if it is there, that will be the package with the highest quality and that has been verified to not have any incompatibilities with SUSE Linux Enterprise. And then the next level would be a development project, such as develop languages Perl, for example, if you need a Perl package. And that would then be built for SUSE Linux Enterprise, so it will be compatible with the Perl version that is on SUSE Linux Enterprise, but it hasn't gone through the same checking as far as compatibility as a package from Package Hub. And then the last instance would be if you find a package in somebody's home project in the Open Build service, and then you want to be very careful. So you only want to take those packages if you know the person and if you trust them, right? Don't pick packages that are random in somebody's home project if you don't know them. Build it yourself.
And check the source code.
And check the source, right. So if we put it all together, the big picture, this is what it looks like, right? So we have Package Hub, which is basically driven by the community and verified by SUSE package maintainers to provide stuff that is in addition to SUSE Linux Enterprise. Those packages are community maintained and you get community help. So if you have an issue that is in Package Hub, the same issue will exist in the OpenSUSE project. So if you send an email to the OpenSUSE mailing list, somebody is probably going to help you. Then there's the SDK, which basically covers all of SUSE Linux Enterprise. The SDK is of course maintained, but there's no support. You can't call and say, I'm using this package from the SDK and I need a fix yesterday, right? That doesn't work. Obviously, if there's a bug and you tell us about it, we are interested in fixing it. But no support basically means you're not going to get 24/7 response time on things in the SDK. Then there's SUSE Linux Enterprise Server, which has all the modules that we talked about. There you have full support, fully maintained, and support again means you can call us and according to your support agreement, we will react accordingly. And get you a fix as fast as possible. And then there's the solid driver program, which is supported by our partners when they build primarily build for kernel modules. Okay, in summary, so the base or the core provides a stable foundation that we build everything around. The module provide easy ways for us to keep up with technology as it changes, fast-changing components. The modules have their own life cycles, okay? So whenever you use something from a module, be aware that the modules have different life cycles than the base and from each other, okay? Then there's the solid driver build service, which again is for partners, and there's Package Hub to provide additional functionality. And with that, thank you for your attention, and we're happy to answer any questions you may have. Yep.
Regarding PHP 5, just as an example, it's part of a module, I understood.
Yeah.
That's not the point.
Right.
And it will launch out of this module in the near time, in the near future. Will disappear, it will be removed by SUSE from this model, from this repository. And therefore, it won't get any security update, for example, anymore.
Correct.
But in the environment, they are probably still installed.
Yeah.
So how are we supposed, because it's still installed, but it has vanished out of the module, and we don't know that. How can we make sure that there aren't any SUSE packages which aren't on support anymore? How can we make sure that we don't have this in our environment?
What we do in this cases is normally we decide depending, I'm generally speaking currently, not specific for PHP. What we do in this cases is one of two ways. The first one is we make an update that removes that package, where a pop-up comes, sorry, this update will remove the package because it's not supported any longer if you don't want to. We did this in very rare cases where we had legally no other way of making sure that you as customer are not inflected by some problems. The second way, which we prefer in these cases because it's much more graceful, to be honest, is that we, in these cases, release an update that obsoletes the package with the newer version. So going to PHP 5, I can't tell you currently how we will handle it in 1.5 years, but my expectation is that at that point in time, we would release a PHP 7 update package that makes sure that the PHP 5 packages are replaced by PHP 7 packages.
So basically the package stays in the repository, but it becomes marked as obsolete, right? So then, and the new package that obsoletes it says it provides the old version, so that when you run zipper up, you automatically get updated. So when you run zipper up, you really want to look through your package list, right? But that's how you know. So we are trying to make sure that your system stays up to date and that you're not running packages that no longer get support, right? And we're doing that through the packaging mechanism, right?
There's also a second mechanism that we're currently preparing for that. We have added with SP2 to the super command the lifecycle parameter, where you can do super lifecycle and it gives you information about a specific package where the lifecycle is, the service pack you're running on, or the code stream itself, right, when this will end with maintenance lifecycle. And we are considering of going the next step then to automatically warn you or make a mechanism that gives you a notification as an admin. Hey, you have your 4 machines where you have this, and this package that will run out of lifetime in the next few weeks. Right. That's something we are currently working on and planning. We are very careful of introducing it because it doesn't make sense to do it in a way where you suddenly get flooded without any real, how to say, guidance what to do, and just popping up things without need or sending emails without need is also not the way we want to do it. We have still for PHP, which will be the first big chunk of packages where this will happen, a little bit of time, and we're trying to find there a good solution to also give you a heads up so you're not surprised when it happens. Right. We don't want you to be surprised that package, oh, it has ended with its lifetime a week ago or in 2 weeks. That's a little bit short, you know. If you have 1 machine, it may be okay. If you have 10,000 of machine and it says to you, hey, in 1 week you have to replace that all, you might be a little bit frustrated. So it needs also some mechanism to say, I want the information a month before or 2 months before. Yeah. We're a little bit behind on that with implementing it because there are more implementations or considerations.
So we haven't really crossed any of these thresholds yet, so we're still working on making it as easy and obvious to you when you're approaching those thresholds, right? We're not just going to cut you off and leave you hanging. Yeah. Okay. Any other questions? We're already over time, but we can maybe take a short one.
I come from a CentOS kind of background, and their approach for extra packages. Would you say Package Hub is sort of your take on that same idea?
Very similar, yes. Very similar, yeah. Okay, thank you.
Thanks.